Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Tentro Quadtropy by Skojo, and here are the rules. We have Quattro Quadri rule set, where we need to place a digit from 1 through 9 into each cell so that digits don't repeat in rows, columns, or boxes. Very nice. I like how he's using that explanation. Perfect. We have regional constraints, where each constraint type may contain no repeated digits anywhere in the puzzle. So that means for each constraint type, there cannot be repeats on that type of constraint. So for example, this is a constraint type and this is a constraint type. There cannot be repeats on these constraint types. There is a V here and a V here. There cannot be repeats on long cells that share a V. There are these thermometers. There cannot be repeats anywhere on these thermometers. So those are examples of how regional constraints work. So what are the constraints? We have Tentropy lines, where every set of 4 adjacent digits on a hollow peach line must contain a digit from each of the X pairs, 10 pair subsets of 1, 9, 2, 8, 3, 7, and 4, 6. A 5 may not appear on a Tentropy line. If a Tentropy line contains fewer than 4 digits, those digits must be from different subsets. So as an example, you could have, say, something like 4, 9, 2, and 7 here. And this would be valid on this Tentropy line, because for every 4 adjacent digits on it, you have to have one of each digit from the subsets 1 and 9, which we do, we have a 9, 2 and 8, which we do, we have a 2, 3 and 7, which we do, we have a 7, and 4 and 6 here, which works because we have a 4. So that's an example of how Tentropy line works. We have Renban, where digits on a pink line form a set of consecutive digits in any order. So for example, if this were, say, a 6, this would have to be 5 or 7 to be consecutive with it. And these must form a set of consecutive digits also. And those are examples of how Renban works. For thermometers, digits on a thermometer increase from the bulb to the tip. So you could have something like, say, 1, 3, and 4 here, and that would be valid because we are increasing from the bulb to the tip here. What you could not have is something like 1, 5, and 4 here, because this is decreasing from the 5 to the 4 here. And that's an example of how thermos work. We also finally have X's and V's, which are separate rule sets. X's, digits on an X, or basically that have an X in between them, sum to 10. So if this were 9, this would actually have to be 1. Okay, that actually works. And for V's, digits on a V sum to 5. So if this were 4, this would also have to be 1. And that works. And so those are examples of how X's and V's work. And remember, we have the regional constraint, where every constraint type cannot contain repeated digits. So if we had 9, 4, 2, and 7 here, that means the rest of the Tentropy lines cannot contain those digits. Same with V's. If we have a 1 and a 4 here, that means the other V cannot contain 1 or 4. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. So, these add up to 1 through 4. Because to add up to 5, so this is 1 through 4. So these have to be different digits, because we know there are no repeats on any for the regional constraints for any rule set. So then this is 6 through 9 here. To add up to 10. This cannot contain either of these digits. So this one we're going to mark. So we're going to mark the sets of 10 as constraints. So this one will mark green. So that's the green set of 10. This will mark red. This has to be a different one, so we'll mark that as pink. And this has to be different digits. It cannot be pink or green. It has to have a red here, so this is red here. And then we'll mark this as blue. We know each digit has to appear on a tentropy line because there are no repeats on a tentropy line, and we can't have 5 on a tentropy line. So that means where is the low? So this is pink. So for every 4 digits, these can't be green or pink. So this has to be a blue-red combination. That means for this adjacent 4 digits, what are we missing? We have a pink, we have blue and red, we are missing green. So that's green here. And then this must be pink also, because we have pink here. Well, these cannot be the low blue or reds, because if they were, then, well, they can't be because we have a low red, blue, and red in the box. So where are the low blue and red on the tentropy line? They have to be here. So this is 1, 2, 3, 4, the low blue and red. These must be the high blue and red here. So this is 6 through 9. This cannot be high red because both reds are here. So therefore this can't be high red, it's high blue, which means this can't be high blue, it's high red. If the blue and red pair are 2 and 3, that means these must be 7 and 8 correspondingly. This has to be the high pink, and this must be the low blue, or low green. So that means since this is high pink, this is low pink here. We already have red, green, and blue on the x's, and an x can never contain a 5. So these have to be the blues. And this can't be high blue because of the high blue in the column. So this is low blue here, this is high blue, and both blues eliminate blue in the rest of the row. So this can't be blue, this is low red, this is low blue here. Low red means this can't be low red here. This is high red, this is low red there. If, again, this was 2, 3 as a pair, that would force this to be 7, 8 as a pair. And then, well, we could have this Ren band. 4, 5, and 6, that does work. Huh. Where is the low pink in this lower left-hand box? Can't be here, can't be here, it must be here. So this is low pink here. Where is... What are the remaining digits, I guess? We have 5 possible, and then 1, 2, 3, 4. So this can never be 1, 2, 3, or 4. So it cannot be low blue. So low blue has to be either here or here. Can't be here. Because this digit has to be greater than another digit, and these digits are 1 through 4. So if we try to have a low digit here, we'd have all the low digits accounted for in this lower right-hand box, and this would have to be at minimum 5. So that doesn't work. So this has to be 5, 6, 7, 8 here. This must be greater than that, so it's 6, 7, 8, 9. And this has to be less than that. So it could be 1 through 4, or 5, 6, or 7. So the low blue is one of these two. We have high pink and high blue left, and then a 5. Let's make the pink actually yellow. Because I want to use pink for 5s. Low yellows here. This cannot be blue or red. It can't be yellow, so this has to be 5 or green. Interesting. Yellow and green add up to V. So can this ever be green? If it's low, it could be. Interesting. So I think 5 has to be one of these two, right? If this is green, obviously if this is 5, it's 5. If it's green here, it cannot be the high green with it because low green and low yellow add up to 5. So the only way yellow can be consecutive with green on a 3-length Renban would be if, well, it'd have to be 2 and 3. Okay, so that doesn't work. So this cannot be green here. If we tried to have a green here, and it cannot be high, because that would be 6, 5, and 4 possible on the Renban, but that would force this to be 6 and 4, and then yellow low would be 1. So 1 could not be there. So one thing we know is this can't be 1. Can it be 2 or 3? And I think the answer to that is no. If we have 2 here, that would force this to be 3, 4 as a pair, or 1, 3, but then that would eliminate all possibilities for these cells here. So this can't be 2. This is 3 or 4. So yellow's 3 or 4, which means it has to be with 6 or 7. But we are guaranteed a 3, 4 here in this lower left-hand box. We are guaranteed a 3, 4 for this V. That eliminates 3 and 4 in the rest of the box. So this can't be 3, 4, and 5 here. It has to be 4, 5, and 6. So yellows, the low yellows are 4. So these are 4, and this must be 6. That makes this a 2, 3 pair, which makes this a 7, 8 pair. This has to be 1 and 9 then. That forces this to be 1. This has to be a 2, 3 pair on the Tentropy line. This has to be 2, 3 with 7 or 8 there. This has to be 5 and 6 as a Renban because of the 2, 3 pair in the box. So this cannot be pink or green. It has to be 5, and this is yellow high as a 6. Where is the low 1? Cannot be here, so it must be low 1 here. And this is high green. Low 1, low green, sorry. 1, 9 here. That means this can't be 1 or 4. Because of the 1, 4 in the box. This can't be 6 because of 6 in the row. Remaining digits in... So 9 has to be one of these 2 digits here. Because it can't be here in column 3. What are the remaining digits in column 3? We can't have 1, 2, 3, 9, 4, or 6. So no 1, 2, 3, 4. So it could be 5, 7, 8. And we have a 5, 7, 8 triplet in this upper left-hand box. So the rest of the box cannot be 5, 7, or 8. This has to be greater. This cell has to be greater than that. So this is at least 3. Cannot be 4, cannot be 5, 6, 7, or 8. So this is 3 or 9, and this must be 2, 3, or 9 here. Okay. So we know this is pink with the high green. No, not high green. High red. I actually did that correctly. um, this has 6, 5, and 4 on this red band. Remaining digits here cannot be 1, 2, 3, 7, 8 because of the 1, 2, 3 pair and the 7, 8 pair in the row. Can't be 4 or 9. So no 1, 2, 3, 4. It could be 5, 6, no 7, 8, or 9. So this is 5 or 6. Okay. You cannot have 4, 5, 6 on this red band, so either it's 7, 8. Cannot be 2 or 3. Actually, this can't be 2 or 3, period. So what can be on this red band? It could be 1, and no 2, 3, no 4, 5, 6. It's 7, 8, and it cannot be 9 here. So if this is 7 or 8 here, this has to be 7 or 8 here, because it can't be 4, 5, 6. Cannot be 9 because of 9 in the column. If this is 1, this has to be 2. Okay. So those are those possibilities. This cannot be 7, 8 as a pair, because if this is 7, 8, that would eliminate all possibilities for that cell. So this must be 1 and 2. So we have 1, and this is 2, which means it's the blue 2. So all the low blues, it's a low blue, sorry, are 2s. All the high blues are 8. All the high, that means this cannot be 8 here, no 8 here. Let's just remove the coloring here. No 2 here. So this is a 3, 9 pair. Low reds are 3. So this can't be 2 or 3. This can't be 5 or 6 because of the 5 or 6 in the row. I should have had that earlier. This can't be 7 because of this has to be greater than this digit. The high reds, so we already do the low reds. The high reds are 7, which eliminates 7 in the box, so this can't be 7. This is 8, which forces this to be 9. This can't be 7 here, so it's 5, 6 as a pair. This 9 eliminates 9 in the rest of the thermometers, so this can't be 9 here. This is 3, that's 9. Okay, so let's make sure the regional constraints are correct for Tentropy. We have 1, 2, 3, 4, 6, 7, 8, and 9. No repeats. For the V's, we have 1, 2, 3, 4. No repeats. For X's, actually for red bands, we have 1, 2, 4, 5, 6. No repeats. For X's, we have 1, 9, 2, 8, 4, 6, and 3, 7. No repeats. Remaining digits. So this is at least a 4. Because it can't be 1, 2, or 3. This is greater than it. It must be at least 5. This cannot be 8 or 9 on the thermometer. And cannot be 7. So this is 4, 5, 6. This, because of the 5, 6 pair in the column, this can't be 5 or 6. So this must be 4. This is greater than 4, but cannot be 8 or 9, so this is 5, 6, or 7. Remaining digits in this upper right-hand box are 5, 6, 7, 8. This cannot be 5, 6, or 8 because of the 5, 6 pair and the 8 in the column. So this is 7, which makes this 5, which makes that 7. This can't be 5 or 7, it's 6. This can't be 5, 6, or 7, it's 8, which makes this 5. And this can't be 6 because of the regional constraints, so this is 5, and that's 6. And that's how you solve this puzzle. Yeah, I wanted to do this because I kind of wanted to introduce Quattro Quadri, which is it's usually an easier form of variant Sudoku than normal Sudoku. But there are some things that you might be used to in normal Sudoku which you cannot carry over for Quattro Quadri. Um, Namely that you're not guaranteed all 9 digits in every row column and every row and column. You're guaranteed it in every box though. And then it also introduces regional constraints and Tentropy line. So it's a nice little puzzle that has a lot of variants that aren't necessarily the most common, I would say. Um Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.